Welcome to the channel, Professor Wilcox, where today we do section 4.5, Systems of Linear Inequalities. So we're going to start section 4-5 for those of you that are online. We're going to have, like I said to you, the big brother of yesterday's lesson. It was just putting a line on a graph, right, and shading it. That's one line. Now we put multiple lines on the same graph. If I have a line like this and I shade below, we'll call this the pink. And if I have a line like this and I shade above with the green, the overlapping section is what we are looking for in this lesson. And you can see if you use highlighters, pink and yellow, make this really nice orange color. Well, hello to Algebra 1 class. I am sure that you have already seen the video or learned the lesson from 4.4, which is graphing a linear inequality. And now we are going to graph a system of inequalities in two variables where we have more than one graph, more than one line and shading in one graph. And so you probably saw from the snippet from a couple of years ago during mask wearing learning that we are going to possibly, if you want, this is an option, using different colored highlighters and markers to show where your overlapping regions are going to be, okay? And so let's get our learning target down, which is very, very simple. I can graph a system of linear inequalities. The chart that we are using for this is going to be the exact same as the last lesson, and so I'm not going to drag this out and explain it in as much detail, but we have a greater than symbol here in the middle and a less than symbol here in the bottom center, which if you have either one of these two symbols, that means your line is going to be dotted, which is going to look something like this. I just put that in the box to help remind us about that. Greater than and greater than or equal to go together, because if you have either one of these, greater than or equal to, that means you are going to physically shade above the line with one particular color. So I shade above wherever your boundary line is going to be. And then if I have greater than or equal to, less than or equal to goes along with it, which is going to be below. And so I'm going to actually physically shade with a different color below the line. Use two different colors for the different lines. And then when you have greater than or equal to, less than or equal to with lines under here, it means the boundary line is included. And so you are going to have a solid line, which is going to look something like this. And then you put your favorite letter up in the corner to fill in the rest of the chart. So let's try a couple of these and see what it is that we are trying to do here. For example, 1, we have y is greater than x minus 2. And we have y is less than or equal to negative x plus 1. So we're going to graph each one of these, and I'm going to look at the b value of the top equation, which is negative 2. I'm going to go down 2 and put a point. The slope of the top equation is 1, because that's the number in front of the x, so that's going to be 1x. I'm going to go up 1, right 1, and up 1, right 1. Okay? Now for this, we look at the symbol. The symbol is greater than. And so back to the chart, greater than is here, which means my boundary line is dotted, and we are going to shade above. So we're going to graph a dotted line through here. Put arrows on the end to indicate it's going to go towards infinity. And we're going to choose a color, any color of your choosing. I'm going to choose yellow, and we are going to shade above that line, which is going to look something like this. Again, if you don't have different colors, it's okay. You can just use a pencil or a pen and indicate where this is going to be sort of the darker region if you're looking for the overlapping areas. My bottom equation is y is less than or equal to negative x plus 1. My b value is 1, so we're going to go up 1. Oops, that's down 1. We're going to go up 1 and put a point here. And my slope is negative 1, because that's the number in front of the x. Call it negative 1 over 1. So we go down 1, right 1, down 1, right 1. And that is going to be solid, which is going to look something like this. And now the shading is less than. So it's less than, which is going to be solid. Less than or equal to would be solid, and less than would be below. So then I choose a different color. We'll choose blue, and we're going to shade under or below that line. And you can see the shaded region. What we are looking for in these problems is the overlapping region. This section over here on the left is where it is overlapping. And now what we can do is we can look at different points, okay? An extension of this type of problem I'm going to give you 4 points. This one is going to be 1, 6, negative 5, 0. Just jot these down here and we're going to write yes or no. Negative 1, 2, and 3, negative 2. And I want to ask, are these points in the solution set? So my solution set is the shaded region. Okay, this boundary line is included. This dotted boundary line is excluded. Okay, so we're going to think 1, 6 is right 1 and up 6. Yes, this is in the shaded region of the yellow, but it has to be in both. And so the answer for this is going to be no, that is not in the shaded region. Negative 5, 0 is going to be left 5, 1, 2, 3, 4, 5. Up 0, since this point right here is in the green region, or the overlapped region, we're going to say yes for this. Now, negative 1, 2 is going to be left 1 and up 2, which puts me right here. That is on the line, and the line is solid, and solid lines are included, and so that one is going to be a yes. 3, negative 2 is going to be right 1, 2, 3, down 1, 2, and that's going to also put me on the line. But it's going to be on the line of the shaded region that is blue, and so that one is going to be no. Okay? Let's move on to example 2. My first equation is going to be y is less than 2x, and my second equation is y is greater than negative 3. I often like to take the colors and put them near the equations that you're using so that you can show me which one is which. Okay, you don't have to do that, but I think it's good to be organized in that respect. And so y is less than 2x is going to be graphed. What is the b value? The b value is 0. We're going to plot that here. My slope is 2. Let's call it 2 over 1. So that's up 2, right 1, up 2, right 1. Less than is here on the chart, and that is going to be a dotted line and shaded below. And so we're going to graph this as a dotted line, and we're going to shade below, and I'm going to use the purple marker because that is the first one that we graphed, and that is going to be shaded below, which is going to look something like that. Now my second line is just a negative 3. And remember, when you don't have an x value, that means the slope is 0. And when the slope is 0, that means you have a horizontal line. And so let's go down 1, 2, 3 units and put a point here, okay? And a slope that's 0 is going to be horizontal. This is a greater than symbol, and I look on my chart, that's also going to be dotted, and so that's going to be dotted horizontally, which is going to look something like this. And then I say greater than is going to be above, and so I'm going to use the orange highlighter to shade above, and is going to look something like this. So my solution set is going to be everything that is in this overlapping region over here. And that's really the basic idea. Let's move on to example 3. My equations are x plus y is greater than or equal to 2. Leave a little bit of space, and x plus y is less than negative 3. Okay, so in order to graph these, we have to get y by itself. In this case, we have y here. Let's get y by itself by subtracting x from both sides like this. And so my final equation is going to be y is greater than or equal to negative x plus 2. So we're going to graph that here in just a second. Let's get the other one, y by itself, by subtracting x from both sides like this. And so y is less than negative x minus 3. And so that's what we're going to graph here in just a moment. Okay, I'm going to highlight the equations that we're going to use. This first one is going to be yellow. You can choose whatever color that you'd like to choose. And my second one is going to be orange. So I'm going to highlight this, this inequality here and graph that shading as orange. Top equation has a b value of 2. Let's go up 2 and put a point. The slope of the top one is negative 1, so we're going to go down 1, right 1, down 1, right 1. Now, since there's a line underneath the arrow, that means your boundary line is going to be solid, and so this is going to go like this. And everything that's greater than, it says greater than or equal to the line, is going to be shaded above, and so we're going to shade the line above, which is going to look something like that. My bottom line is this equation, or this inequality. The b value is negative 3. Let's go down 1, 2, 3, and put a point. The slope of the bottom equation is negative, or -1, think of it that way. So down one, right one, down one, right one. And I want you to notice that these two lines are parallel to each other, okay, which you know never intersect. And the bottom equation is negative, or less than, so that means it's going to be below, and so I'm going to shade this line orange below the line. There is no overlapping region. These are going to continue on forever and never intersect. And so this one actually has no solution because there is no overlapping region. Okay? I want you to think about this for a second. Because these two lines or these two regions never intersect, there's going to be no solution or no common points. This region here goes forever in this direction. So there's actually infinitely many points within this region that satisfy the equation. It's called the solution set. And so the solution set, or all of the points that are within this region, will satisfy the problem. And there are infinitely many of those. Last problem for the day is example 4. Is going to be y is greater than 2x minus 3. My second equation is 2x plus 3y is less than 6. Let's graph these ones. Now this one already has y by itself, and so that one is going to be all set and ready to go. I'm going to show you on this last example how to graph without markers. If you only have a pencil, you don't have any highlighters at home, if you have just a pen, whatever that's going to be. To graph the bottom one, we have to get y by itself. We're going to first subtract 2x from both sides like this. 3y comes down. And I'm going to write this as negative 2x plus 6. Generally, we put the x value first. And now let's divide everything by 3. And so my final inequality is going to be y is less than negative 2/3. This is negative 2/3 x plus 2, because 6 divided by 3 is 2. I'm going to use the shading crisscross method, and I'll show you what I mean by that. The top equation has a b value of negative 3, so I'm going to go down 3 and put a point. And we're going to go up 2, right 1, up 2, right 1. Okay? So this one is greater than. There is no line underneath the arrow, so this is going to be dotted. We're going to graph this as a dotted line, something like this. Now, greater than is above, and so what I'm going to do is I'm going to try to shade these up and down, and you'll see what I mean in a second. The other line will be shaded side to side, and then you'll be able to see where the overlapping region is if I don't have markers for this problem. Okay, my b value of the bottom line is 2, so let's go up 2 and put a point. My slope is negative 2/3. We'll go down 2, right 3, down 2, right 3. Okay, less than is also dotted, so we're going to put a dotted line through those points as well. Again, some people do call those dashed lines. Dashed and dotted would be the same. And now less than is going to be everything below the line that we just graphed. And I'm going to graph this one side to side. Everything underneath is going to get a right to left motion. And so you can see the shaded overlapping region is going to be everything over here, because that is where my crisscross or up and down and left to right regions intersect. And so my solution set is going to be everything that's over here. And you can shade it a little bit more just to indicate that you know what the shaded region is going to be. So that's about it. The lesson is complete, and therefore the chapter is complete. I hope this has been helpful for you, and let me know if you have any questions. I can be found in room 312, or you can contact me on Remind. Thank you very much. Enjoy the day, and have a great one.